Hi, thanks so much for being here today. I'm Jess Ingrassellino, the engineering manager for data acquisition and Telegraf here at InfluxData. We know that the most important part of working with your data is getting your data into the right place at the right time so you can take advantage of the insights provided by InfluxDB and get the most out of your data. Today, I'll tell you about Telegraf. I'll tell you about the client libraries and API. I'll tell you about the command line tools, the UI, and the Flux from function as ways that you can work to ingest your data in InfluxDB. I'll also be sharing with you some data input best practices so you get exactly what you want and need from your data. So first we'll start with Telegraf. Telegraf is a plugin-driven server agent for collecting and sending metrics and events from databases, systems, and IoT sensors. As you can see on the slide, we have a number of plugins, and that's just the tip of the iceberg. Written in Go, Telegraf compiles into a single binary with no external dependencies and a minimal memory footprint. Next slide, please. So what's so great about Telegraf? Telegraf collects data from an impressive variety of inputs, over 175 and counting, including some of the most popular for building data pipelines, and can process, aggregate, and output your data to a variety of sources, including InfluxDB, for a total of nearly 300 plugins. The single binary means that with a single install, you have all of the functionality of those 300 plugins, since you can run multiple plugins in a single instance of Telegraf. And if you need data from a source that isn't included in the binary, whether it's a plugin for a niche protocol or a plugin for an internal or proprietary data format, you can build that plugin in Go or another language and run it using execd. Execd provides a shim for plugins that are written in Go to take advantage of everything built into the Telegraf agent. If you're looking for something that Telegraf provides in the binary, you can get started easily through simply editing a TOML file to set your configuration, or you can even use the InfluxDB UI to create configuration files for your desired plugin. We'll investigate this in more detail later. Providing the core functionality to the plugin is our robust Telegraf agent. So what's great about this is that using the agent configuration block, you can set the basic parameters related to how Telegraf fetches, batches, and flushes data for all of your plugins. So you can think about this as sort of a way to set data globally for everything. To prevent data loss, there is user configurable in-memory metric buffer, which can help keep your data pipeline flowing if your output is temporarily unavailable for any reason. Your data can be streamed, allowing for multiple metrics to be sent at a time, allowing it to be done in parallel, and ultimately allowing for higher throughput of your data. Throughout, you'll have the ability to route metrics by dropping, passing, tagging, or acting on the metrics, and you can chain processor and aggregator plugins to achieve complex data computation before ever sending data to its final destination. Next slide. Getting started with Telegraf is simple. On the InfluxData.com downloads page, you'll find the latest version of Telegraf available for your platform. We support OS X, Windows, and several flavors of Linux. On the documentation page, as well as in the open GitHub repository, you'll find everything you need to edit the config file, to collect the data from your chosen sources, and send that data to your InfluxDB instance, as well as any other tools that you may be using. Or if you prefer, you can edit that in the UI. Finally, you can simply run your Telegraf, and the agent will immediately start collecting your data and sending it to your InfluxDB instance. If you have more in-depth questions about Telegraf, we have so many ways that we love to engage with the community to offer to help. You can read our blogs. You can look at the InfluxData YouTube channel and watch the different instructional videos that we've made to get started. Or you can always reach out to our Telegraf community Slack channel and ask questions. Our team responds there daily, and we are always happy to help people get started with Telegraf however we can. Next slide, please. While Telegraf is popular, it isn't the only player in the data acquisition game. InfluxDB client libraries are language-specific packages that integrate with the InfluxDB v2 API, allowing you to build small, fast, and focused methods for data collection right into your applications. Next slide. Currently, we offer client libraries in Arduino, C#, Go, Java, Kotlin, Node.js, PHP, Python, Ruby, Scala, and Swift. This means that any of your applications built in these languages can send data directly to InfluxDB using the InfluxDB Write API. To use these client libraries, you can download the binary via the command line or with assistance from the UI. Then you'll need your bucket, auth token, and org data. And once again, you can find this in your UI, or you can get that data via the Influx command line. Once you have all of this information, you'll import packages, specify your data entry point, and create the methods in your application to write the data to the Write API. So if you want to be building data collection directly into your application and Telegraf is too big, too much, not the right solution for you, then I'd really strongly suggest thinking about trying out one of our client APIs. Also, we have the ability, we've had some of our APIs that have been, I know, started in the community. So if you're thinking, hey, I'd love to see an API that doesn't yet exist, you can go ahead and build an API for a language that you're interested in. We are always loving to see what our community is coming up with and contributing and using to get data into Influx. Next slide. But maybe you don't need to build your data writing into an application. Maybe you just want to go direct. So in that case, you can write directly to the Write endpoint of the InfluxDB API. Next. You can write directly to InfluxDB API's Write endpoint using an HTTP post request. Your post requests can be written with these following parameters, and they are required. You need your organization, your bucket, your data collection precision, whether that's a second, millisecond, an authentication token, and your line protocol data passed as plain text in your request. You'll see that I've included a link to the documentation in the slides, so if you are watching the talk at a later point, you can go ahead and get detailed information on anything I'm talking about throughout the presentation. Next slide, please. So in this example, you can see how I used curl to set up a post request to InfluxDB Cloud. You'll notice that I have all of the elements there, a post request with the org, the bucket, and the precision defined in the URL. Then you'll notice the header flag containing the auth token, as well as the raw data containing all of the lines of line protocol. If you want to compress your data when writing using the write API, you can add another header line with the content encoding header set to gzip. A note about compressing: when you're compressing your write requests, this reduces the network bandwidth, but it increases the server-side load. So as you're thinking about what data you're sending and how much data, keep that in mind as you're making those decisions. Next slide, please. And of course, we wouldn't leave you hanging. We have a lot of friendly response codes to really help you understand what's happening with your writes, including tips on the status of your write. So that way that if something doesn't go the way you expect, you know what to do to try and write your data again successfully, and you know if it's actually happened or not. Next slide, please. So if you're looking to write your CSV and line protocol into InfluxDB, you can use the built-in command line tools. Next, please. Using the influx write command, you can write data to InfluxDB directly via the standard in or from a variety of sources. You can use a specified file, files, URL, or URLs. In order to write this data to InfluxDB, you need to provide the following information for each row of your data: a measurement, a field, and a value. When you're using line protocol, the structure of your data or the way that you write your line protocol determines what piece of information is the measurement, what piece is the field, and what piece is the value. When you're using annotated CSV, the measurements, the fields, the values are represented by the measurement, field, and value columns, and they have annotation rows that you provide which describe the properties of the column. And you can dig into the documentation link again on the slide to really see step by step how to use the annotation rows. To successfully write your annotated CSV, you need to include the 3 types of annotation rows: the data type, the group, and the default annotation rows. The data type annotation row accepts not only different data types, but line protocol elements, and those help to identify how columns are converted into line protocol when using this influx write command to write your annotated CSV to InfluxDB. When you use data types other than datetime in the data type annotation, they're converted to fields when your data is written to InfluxDB. Extended annotated CSV extends the annotations available in the annotated CSV format. So again, if you want to see what the specific differences are between the two, you can go ahead and take a look at this documentation link at the bottom of the slide. Next slide, please. So I wanted to show just a few examples of how the write command can be used to write CSV from a URL or line protocol from a file. There are examples for every way that you can possibly do this in the documentation. So if you have a specific question, I definitely encourage you to go check that out. However, I'd like to go through the structure of these examples so that way that you understand what it is that you're looking at when you dig into your specific use case. In each of these examples, you can see the influx write command, and then you can see the appropriate flags with the descriptors necessary for each flag. If you want to write multiple files or multiple URLs, you'll simply write a flag for each type that you need, whether it's a file or URL, and then you'll specify one file or URL per flag. When writing from the standard in, you can use the influx write command, and the bucket flag, and then instead of using the URL or file flags, you'll go ahead and replace that with the CSV or the line protocol, and that will be written as a string. And you can again write multiple lines included in that string. You can write compressed files by adding a file with the .gz format, which Influx will assume is using gzip compression, or you can use command line compression flag in order to specify gzip compression on a file that doesn't have the .gz naming. Of course, if you want to test out your write before you actually go ahead and attempt to send your data to InfluxDB, you can use the dry run subcommand, which outputs to the standard out rather than to InfluxDB. This is a great way to make sure that everything is writing to line protocol in the way that you expect before you send your data. Next slide, please. So some of us, like me, are really visual, and we want to get an idea of everything that's available to us without having to dig through lines and lines of code or TOML files or digging through the GitHub repo. If you're like me and you love a great visualization, or if you desire a low or no code environment, or if you want assistance in determining your data loading or configuration options, then using the UI to load data may be a really great option for you. Next slide, please. So to load the data with the UI, you'll create and use an InfluxDB cloud account. Now, when you first log into your cloud account, there's so much that you can do that's readily available to you. You're going to look for an option, as you'll see on the left of your screen, that says load your data. Once you click load your data, you will see many options to choose from. And the first place you'll want to go is the sources tab, which you can see in the second image on my slide. You'll see many options to choose from in the Sources tab, including file uploads, client libraries, Telegraf plugins, or templates. You'll see that for this example, I've chosen the Arduino client library. And what I really love about going through the UI is that you have all of the everything really visually and easily laid out so you can quickly scan what you're looking for. So after you select your preferred data loading method, in my case, the Arduino, then you'll be provided with the appropriate configuration, code sample, and token generation options so you can really hit the ground running. Many of these are editable and configurable right within the UI, so you can do all of the work with the specific code that you'll need to get going. So once you've edited your configuration and your code sample, you can then download and save your code and run that code wherever you need it, getting your data flowing into the InfluxDB cloud and ready to visualize in any number of ways. My colleague, Christina, who is an engineering manager on the UI team, will be talking tomorrow about how you can use the UI to work with your data. So if you're interested in how to take this data and make it insightful, meaningful, and impactful for whatever work that you're doing, I definitely encourage you to go ahead and tune in for that talk. Next slide, please. Once you have your data in a data bucket, you can work with that data using the flux from function. Next slide, please. Flux from retrieves data from an InfluxDB data source, and it returns a stream of tables from that specified bucket. Each unique series is contained in its own table, and each record in the table is a single point in the series. Next slide, please. There are some requirements to use Flux to query remote data sources on Influx 2.0, OSS, and cloud instances. So like in our other samples, you'll need to include the host, token, and your organization or organization ID parameters in your Flux from query to query data from these remote buckets. But please take note, Flux from cannot retrieve data from remote 1.x InfluxDB sources. This is for InfluxDB 2.0 sources only. Next slide, please. So we've talked about several ways to get your data into InfluxDB. Now I'd like to share some best practices with you so that way that you can get the most out of your data once it's in InfluxDB. Next slide. First, we're going to talk about how you can optimize your writes. So in order to optimize your writes, it's recommended that you batch your writes together, that you sort your tags by key, use the coarsest time precision possible. For example, if it's possible, using seconds instead of milliseconds for your measurements, for example. Use gzip compression to send data will optimize the time of your writes. And synchronizing your host with the NTP server will also help you to optimize. And whenever possible, write multiple data points within a single request. The more of these steps that you can take, the more optimized your writes will be to InfluxDB, and the faster you can get going with making meaning from your data. Next slide. So sometimes you will want to handle duplicate data points. You have sort of two different options. If you want to make sure, if you want to combine two duplicate data points with the same measurement name, tag set, and timestamp, InfluxDB creates a union of the old and the new field sets. For any of the matching field keys, InfluxDB uses the field value of the new point. So in that way, you can have your duplicate data points combined into a single point. However, there may be times when you want to preserve old and new values in duplicate data points. If that's the case, you can add an arbitrary tag, or you can implement a timestamp in order to actually preserve those data points, so that way that you can have them be involved in whatever data queries that you want to do once your data is in InfluxDB. Next slide, please. When designing your schema, it's important to think about how you're storing and naming your data. Storing your commonly queried metadata in tags, that will definitely help you. Store data in fields, so if each data point contains a different value, and storing your numeric values as fields. So for example, tag values only support string types. Really make sure that you know exactly what what the tags do, what your fields do, and what shape you want your data to take before you send it, so that way that you don't have any issues once your data is in InfluxDB. When you're naming your data, avoid using keywords and tag and field names, and avoid using the same tag and field name in order to encode your data, and avoid storing more than one piece of data in one tag. Finally, you want to avoid ending up with too many series. So your tags can contain highly variable information like unique IDs, hashes, random strings, and each of those things can lead to a large number of series. So sometimes we call this high cardinality. Now, high cardinality can be a really big driver of memory usage for many database writes. So InfluxDB uses measurements and tags to create the indexes and to speed up the reads. So that's really helpful for that aspect of things. But if you have a system with memory constraints, you may want to consider storing your high cardinality data as a field rather than a tag, so that way that you can avoid having too many series for your data. So I really hope that this talk helped you to clarify all the different ways that you can go from raw data, wherever it is, whether it's using one of the many Telegraf inputs, whether it's using the right API directly or using the right API and building it into your application for something that's fast and bespoke, whether it's using the command line tools or digging into all the things that you can do right from within the UI to get data started. If you have any questions and are curious to really dig into each of these topics more in depth, because today I just wanted to give you an overview of all of the things that you can do and all the power that you have. But if you want to dig into any topic into more depth, there are so many things that you can do. You can reach out to us in the forums. The community Slack channel has so many people who are really in-depth experts on every type of data acquisition. And not only that, but our community Slack has users who have deep experience with so many different use cases. So it's a great place to dig into very specific problems that you might be having or different use cases that you want to look into for your data acquisition. We also have a blog, and we regularly post different IoT use cases, as well as different stories about how people are getting their data into InfluxDB and getting insights from that data. And our YouTube channel has tips, examples of implementation, and more. And of course, thanks again for attending InfluxDays. I think we have some time, Chris, to have some discussion maybe. Thanks so much, everybody.
Hey, Jess, that was really awesome. I'm so impressed that we're almost at 300 Telegraf plugins. I mean, that is, once again, it's a testament to the huge support we have from the community. I think when I started at Influx, I think we were talking about like 55, 60. And that was, the end of 2016, which is just phenomenal. And I think the diversity of the plugins is also, really impressive. Maybe, Jess, we should just talk a little bit more about the different types of plugins that you mentioned at the beginning of your talk. So there's the input plugins, there's output plugins, there's processor plugins and aggregators. And let's just briefly reiterate, what are the differences between those? Because I think everyone knows the inputs, but I don't know if they really necessarily know the other ones, and they are really cool.
Yeah, they're really cool and they're really important. So of course you have the input plugins, and they just cover such a vast array and they can be extended. But then the processor and the aggregator plugins are really where you can make some magic happen. So the processor plugins for Telegraf really allow you to basically do what they say: aggregate and process your metrics. So with processor plugins, you can transform your metrics, you can decorate your metrics, you can filter your metrics, so that way that they can emit results based on the values that are being processed. So for example, you might be printing all your metrics with a processor. You might be adding a tag to every single metric that passes through. You might be adding more than one tag to all of your metrics that pass through. So in this way, maybe the data that comes from one of the inputs, for example, is not at the granularity that you'd like it, or, and this is a way for you to really work through that and to make sure that all the insights that you like from that data can come from that data. So the processor plugins are really, really helpful ways to do this. The aggregator plugins are actually a little bit more complicated. So what these allow you to do is actually get new metrics from the metrics that you have. So this might be that you want to get a mean, a minimum, a maximum, standard deviation. So these are ways that you can use the aggregator plugins. Now, when you think about this, you can start to really see the power of processor plugins and aggregator plugins together. Because you can say, okay, I have my raw data. I want to label, tag certain aspects of my raw data, and then maybe you only pass data with a certain tag to the aggregator to have it aggregated, and your other data doesn't go to the aggregator. So you can start really doing some data processing right within your data pipeline. And then once you are actually, ready to get your data to the output plugins, you are working with the data set that you really want to be working with in the form that makes the most sense for you, for your application. So there's some really incredible things built into the processors and aggregators. And I think another, I'd really like to point out Starlark as a great option, because a lot of people come to us, a lot of community members and even paying customers, and say, yeah, you have all these plugins, that's great. I'd really like to process X data in Y way, and there's not a plugin for that. And with Starlark, that's actually not a problem. So Starlark essentially uses a Python-like language, and using that language, you can write a script to literally do whatever data processing that you want. And then Starlark takes that script, runs that script, processes your data, so you can literally have bespoke data processing built into your data pipeline, which, when you think about it, is an incredibly powerful tool that a lot of people don't know exists, but it makes working with Telegraf in particular really, really extensible. Now, take that and sort of say, okay, I have all these ways to interact with my data. And then you say, and I have proprietary data. I don't want to, great, yay, Telegraf, and I don't want to write a community plugin. My stuff is proprietary. So you use execd, you write a plugin, an input plugin that is bespoke to your data structure, to your proprietary information. You process it in a proprietary way through Starlark, you aggregate that data, and then that data, you output it to InfluxDB, and we do have outputs that send to other visualization sources. So what that means is that you really have ways not only to get time series insights from Influx, but you can also get different kinds of visual insights if you're using other data visualization tools and you'd like to output your data to both places, and you can dual write. So it's not like you have to say, oh, I really love to use InfluxDB for processing all of this data and gaining insights from it, but I want to use another visualization tool. Cool, do that. We let you do it all. And so I think that there is really a lot of power in understanding what is outside of those input plugins, because people pay so much attention to what you can get in. But a lot of people are not aware with how much power that you have once you actually take the time to dive into the capabilities of the processor and aggregator plugins, and that people are not aware that you can actually really completely build your own solutions, so that way that when you're sending your data to InfluxDB instance, when you're sending it to the cloud, it is exactly what you want and need it to be.
Yeah, I mean, you're so right. I feel like we give so much credit just to InfluxDB for processing, but really, these set of agents, called Telegraf, actually could do more than just collect data, just as you mentioned. They can,
Yeah.
and especially when you think about, the solutions that our developers are building are probably going to be bespoke to their situation. They might need a process at the edge. They might need to aggregate here. They may not. I mean, whatever you want to build, just like you said, right? You want to make sure that it fits their solution.
Yeah, absolutely. And when I think about really, when I think about the other ways that we have data too, the if somebody is in a situation where they're like, hey, I want this built into my application, I think that's something that our APIs make really, really great, is that you can extend writing data right from your application. So if Telegraf just isn't the solution, and for a lot of reasons it's not the solution. So yeah, if you're running and you're on the edge and you want to do IoT, then yeah, Telegraf is such a great solution for that. And if you're like, hey, I want to build this into my application and I just want to hit my API endpoint directly, I love the fact that we really have sort of a ever-growing group of client libraries that people can use to truly build out exactly what they need and in the language that their developers are used to working with. So, I just think that I love all the fact that there's so many ways truly to get data from wherever you have it, wherever you're getting it. And we keep providing more ways to get that data into InfluxDB. So, I definitely, something I encourage people to do is, if you've never realized or thought about the client libraries and you're building applications in any of those languages, really take a look at using those to get your data and see if that's a way for you to have just that focused, fast set of writes, because it's just another great way. It's another extensible way to get your data into InfluxDB, especially if if again you want it to be directly as a part of your application and not something else that you're running.
And then I think the client libraries have been rebuilt recently, right? So not only is there that long list that you shared, but we have consistency now.
Yeah, there's consistency. They are internally, they're internally supported, and they are, I believe, although I want to tell people to double check the documentation, but I believe that they are backward compatible to 1.8. So meaning if you are, if you haven't yet upgraded to 2.0, here's looking at someone, I don't know, but if you haven't yet done that, but you want to, you can start looking at the client libraries, and you can build, and then just be ready for a smoother transition, because they are rebuilt. They are really consistent throughout.
And I think you brought up another good point about the direct API, which we don't give enough love to. At the end of the day, it's a really powerful capability, right? And there's a lot of tools that can't do this that we just take for granted. Like just being able to do an HTTP post request is like no big deal for us.
Yeah, absolutely. There's it's certainly, I feel like it's certainly, again, it's in the name, direct API. It's the most direct way to do the thing you need to do. So if you're just, I have to get this in, I want to get something in, quickly, and I want to be able to visualize it quickly, and I don't want to set anything up. I want to test something out. I just want to visualize X. Cool. Hit the API. Hit the direct API.
Yeah.
make that request, and boom, you're in, and I mean, if there's a faster time to awesome, I kind of can't think of it. So
Good
so it is,
point. Good
it's a great
point.
capability.
Good point. And then I think, let's just touch on really quickly on the flux from function. And so, it's, I just want to remind everybody that, of course, we're talking about bringing time series in, but sometimes it's not always just about time series data. Sometimes we need to get a little more contextual information. Maybe it's things like orders. Imagine that you're in a factory, you're looking at this time series data about your production run. You want to also marry that with some other kind of data. We also need to, think about Flux as a way of bringing in that data, not just putting that onto, client libraries and Telegraf as well.
Yeah, absolutely. Which I really, again, something in thinking about all of the ways that we allow people to bring in data, and all the ways that we're continuing to grow the way that we allow people to bring in data. Flux is really exciting. And of course, I am not the creator of Flux. I do not work on the Flux team, but the power of Flux to be able to give that contextual information, that just creates more insights. And really, at the beginning of the talk, I mentioned the data is as valuable as the insights that you can get from it. So we're always looking for ways to help our users get value from their data. We just have so much data. We have so much information in the world, and it's almost too much until you can make sense of it. So yeah, I really, I love that Flux allows for that capability to give an additional way to make meaning of the data right from the get-go.
And Jess, ever since you came on board, the team is much bigger. So are there any other shout outs that you want to give to your team about the great work they've been doing, or some stuff that they're working on that you want to share with the community that, maybe it doesn't, get as noticed?
Yeah. So, what I really love to do is shout out our community maintainers. So we have a group of individuals who are in the community, who we meet with. We meet with them once a week, Thomas, Sven, and Pavel, and these guys go above and beyond, and they are they are working on doing work with the community to do code reviews, to take a look at new plugins, to bring to our internal attention sort of, hey, here is here's really what we feel as a community in a much more in-depth way than we might have of the community just from sort of interacting on the Slack channels, because they have a true commitment to the overall robustness and health of Telegraf as a project. So I cannot thank them enough for their efforts. They're truly an amazing group of people. We love working with them, and you will see that if if you're making a contribution, or if you have an issue, they are so quick to respond and so helpful to answer things. Especially as our team is currently are mostly located in the U.S. time zones. These guys, our community maintainers, are located in European time zones. So, if you are also located in European time zones, or in Asian time zones, Asian Pacific time zones, they're the ones who will often be there to respond, like our first responders. So, Thomas, Sven, Pavel, I can't thank you enough. And then, we've got a really great internship program here at InfluxDB, which I'm not sure that people have realized, but we have 2 interns starting today, and we have our new developer advocate starting today for Telegraf. So, we are continuing all the time to work to make things, to make the product more robust, to to be responding more quickly to our community, because the community is massive, and our team comparatively to our community is a little bit smaller. So, we are always working to be more responsive. So, shout
Smaller,
outs to
but powerful, super powerful team.
Super powerful. Yeah. So, big shout outs to everybody for, all of the support that they provide to our community.
Awesome. So we look forward to seeing all these new team members join us on the Slack channel. So everybody, remember that they're there hanging out. And thank you so much, Jess. This was really great, really enlightening.
Thanks, Chris.
And I know there's a lot more questions, and I promise we'll put them all into the Slack channel and get them all answered for everybody.